Okay, time to start. Welcome to this short presentation during the coffee break. It's Carlo Pompili at Telcred who's going to present secure NFC services with Java card.
Thank you. Yes, good afternoon everybody, and welcome to this short introduction to NFC and Java card, which I suspect are a bit unknown to at least some of you. Telcred, just a few words about what we do. We develop solutions for physical access control. That's hardware and software that control locks and access to buildings. I'll talk a little bit more about what we do that is different from traditional systems towards the end of the presentation, but I'll start by giving a short introduction to NFC, and in particular secure NFC, and how that relates to Java card. NFC, I think many of you have heard the term. It stands for Near Field Communication. What is it? It's a new hardware that's starting to be introduced in mobile devices, in particular mobile phones. So it's like when Bluetooth was a new thing. So it's a new hardware feature of mobile phones. As the name implies, it's radio communication, and it's only works in very short distances, about 2 to 4 centimeters. So it's basically a short-range RFID. 13.56 megahertz, if somebody's interested, which is the same as many contactless smart cards today. So for instance, if you live here in Stockholm and you have a contactless card to travel on the subway, it's the exact same radio frequency and more or less the same technology. NFC has been around for a couple of years, and it's been talked a lot about, but not so much has happened yet. But now it's finally starting to happen out in the marketplace. Last year, there were about 100 million devices shipped, up from 30 million the year before. So in relation to all the mobile phones sold, it's still a very small share, but it's definitely gaining some momentum now. And it's not only mobile phones. The majority of these devices today are high-end smartphones with Android, but it's also other types of devices like tablets and music players and headsets and so on. NFC is a little bit confusing to get your head around, and part of the reason is that when you talk about NFC, it can mean 3 different things, or the technology can be used in 3 pretty different ways that I'll try to outline. The first one is called tag, read, and write. In this case, your phone is active and it's reading a tag, which is like a sticker with a small antenna and a tiny, very inexpensive chip. And when used in this mode, it basically replaces barcodes or QR codes or functions as an alternative to that. So what can you do with it? You can, for instance, read a tag, which would automatically check you into Foursquare or Facebook. You can read a box of something and get more information about the product, that type of application. The other mode is called peer-to-peer. That's mainly used for pairing devices together. So let's say you want to pair your headset to your mobile phone, you can just put them together, or you want to pair your mobile phone to a music player, you do that, and then the actual music stream will most often go over a different channel like Bluetooth or Wi-Fi, but just to tell these devices that now you should start to communicate. Or if you have 2 phones, you can put them together, you can exchange contact details from LinkedIn or something like that. In that case, both of the devices are active. The third way is called card emulation mode, and this is the mode that's also called secure NFC. And in this case, the phone itself is actually passive and is being driven by or receiving commands from an external reader, which is telling it what it wants. And this is what is used when we talk about secure services like payment or ticketing, or for that matter, access control, which is what we do. So I'll talk a little bit more about card emulation mode and how these things work on a more technical level. Basically, you have your NFC phone, which runs an OS, and today that's Android. The iOS doesn't have support for NFC yet. And you have your apps and so on. And if you have an NFC phone, you can be sure that you have at least 2 components. One is an antenna, and one is the NFC controller, which is the small chip that's modulating the actual radio signal. Then you may or may not have a third component called a secure element. If you only use your phone for tag read and write and peer-to-peer, you don't need a secure element. So the secure element is only relevant for card emulation mode. So if you do one of the first two, your app can talk directly to the NFC controller through the API provided by the OS. So Android has implemented support for NFC. What that means is that your Android app can talk to an external device through this API, which is then sending commands to the NFC controller. But if you want to do secure services, that's not enough, because Android is not a secure system, and it's not, at least not secure enough to be accepted as a secure system by Visa or MasterCard or these other companies that want to implement mobile payments. Then you have the secure element, which is a separate hardware chip that's also part of the device. And that chip is a pretty advanced microchip, and it runs its own little operating system, which is called Java Card. And it has some special facilities for storing things in a very secure way. It has some special hardware for doing cryptographic stuff, much like a graphics coprocessor on a PC. And you can write your own little applications that run on this chip, and they are then called Java Card applets. And the chip itself could be part of the phone, it could be part of the SIM card, or it could be on an external media like a micro SD card. And actually all three of these are present in the market today. And that's one of the things that has held the NFC development back, is that phone manufacturers, mobile operators, and others, the payment companies, are not really agreeing on where this chip should be located. And we'll see how that pans out, but I won't go into that too much today. But you have this special chip which you need to have in order to run your secure service. And it has hundreds of different protection mechanisms on a hardware level, and you need some special cryptographic keys to even install something on it, and it's protected against side channel attacks, and there's all sorts of stuff. I won't go into too much detail in that today. But the interesting thing is you can actually use this chip and write your own little application that will run on it. Your Java Card applet. And Java Card as such is not a new technology. It's been around for a long time. If you have a payment card like a Visa card or a MasterCard with chip and pin, you have a Java Card chip in that card. And incidentally, the little copper thing you see on the card is not the chip. That's just a contact, and the chip is embedded in the plastic itself. But this platform has been well standardized by an organization called Global Platform, and it's been around for a while, so it's a very stable environment. And a very good thing is that applets are completely portable between an NFC device and a contactless smart card. So if you write your applet for a secure NFC phone, you can also provision it onto a normal contactless card, or a contact card for that matter, something that looks like a Visa card, and use that. And the reader that is talking to the phone doesn't actually know if it's talking to a phone or to a card. You can use both. So in our system, we use both NFC phones and normal cards, and it works perfectly. It's a very limited device. Typically, these chips have around 80 kilobytes of memory, and there is no difference between RAM and persistent memory. It's the same thing in this context. And the way you write your application is that it responds to commands coming from the outside, and such a command is normally called an APDU. And it's like up to 256 bytes, a command, and then a payload, and then the card will respond and send something back. So it's very embedded, but it works fine. One should keep in mind that NFC is not for large quantities of data. I mean, basically you can send several of these frames back and forth and several commands back and forth, but you need to keep the total amount of data maybe to maximum 1 kilobyte, maybe maximum 2, but not more. But even with this limited device, a very interesting aspect is that you have native support for some advanced cryptographic features like public key cryptography, generating and verifying signatures, and so on. So that opens up new possibilities for secure applications, which is something we use in our solution, which I will then spend a few minutes talking on. So to explain what we do, I first need to just introduce how a traditional access control system works, one you would typically find in a building like this. Basically, you have your card or your key fob or something that you present to a reader, and that will then send a string of characters, some type of serial number, that is passed on to what is called a lock controller. And the lock controller is the box that makes the device whether to let you in or not, and then send that signal to the actual lock. Now, the lock controller will receive the serial number, and it will look in a white list or a black list and then say, okay, this guy should be allowed in. The problem with that is that when the situation changes, who is actually allowed to enter through this door, the lock controller needs to get this information from somewhere. So it needs to receive frequent updates. And that's why traditional access control systems look like this. It's basically wires running from every door to a box, and then from that box to a bigger box, and then from that bigger box to a central administrative system. And that's okay in a building like this, especially if you only have access control on a limited number of doors, like the entrance doors to the building itself. But it doesn't work so well if you are trying to protect this type of environment. If you're a power company and you have 1,000 of these little stations spread across the country, or you have equipment that's sitting in the basement of residential buildings spread across the country, or you have 5,000 cell phone towers spread out over a large area, or if you're talking about shipping containers that's going to be sitting on a ship and you want them to be locked as well. So traditional access control systems were not designed for this type of environment, and they don't work so well because they require this constant connection. So that's what we do. We develop a solution which works offline, in the sense that the hardware which controls the actual lock doesn't need to be connected to the rest of the world, and we can still handle things like somebody should have a temporary access right, the list of allowed users changes, and so on. So how do we do that? Well, instead of just sending a short serial number, this Java card technology is advanced enough that we can send much more information, and we can do a bit of negotiation back and forth between the reader and the device itself, the NFC phone or the contactless smart card. So what we do is that we have our device, the card or the phone sends something which you can describe as a ticket. And this ticket contains the access rights for that specific device. So instead of my device telling the lock who it is, and then it's up to the lock to know whether it is allowed or not, it tells the lock which locks it can open, or it has the rights to open. And then the lock is only aware of its own identity. And if you think about it, this is actually how traditional tickets work. If you go on a train and you show your ticket to the conductor, and they will say, okay, this looks like a bona fide ticket, and it says on it that it's valid for Johan Persson and for a train trip from Stockholm to Gothenburg. And this is that train, so therefore I will let you go on the train. Of course, you then have to update the device you're carrying instead of updating the lock. But if that device is a phone, we can easily do that. And the nice thing about this is that you don't need to be connected the whole time. You only need to be connected when you receive a new ticket. And if you do that once per day or once per week, it's pretty easy to have this model where you receive updated tickets relatively frequently. But then when you're standing there at the lock, neither the lock nor your device needs to have any network connection at all. And the way that Java card comes into this is basically then that we can store a little bit more information on the card. We can let the card talk to the server and receive updated tickets. But we can also use Java card's built-in cryptographic functions to do things like strong authentication. The lock is sending a challenge to the Java card device, which will then sign that challenge and return the response. And then on the lock side, we need to verify. So this system, this is a bit too short time to dig into the details, but basically the security model for this is built around digital signatures. So the tickets themselves are signed by the central server, and then we verify that signature on the lock side. And then we have the problem that the public key cryptography is a pretty resource requiring type of cryptography. But with Java card, we can use that also on the lock side to do very efficient cryptography. So we actually use Java card in two ways. One is we use it in the NFC phone or on the contactless card, but we also use a small smart card chip in the lock to do the cryptographic stuff. So this is a product that we are developing right now. It's an add-on for a mechanical lock. It runs with a tiny processor. It's real hardcore embedded stuff. It's a small ARM7 processor for like €1. It runs on 4 AA batteries, but it can still do public key cryptography. And the reason it can do that is that we also use a Java card, smart card, as a cryptographic coprocessor for the lock. And it works fine. It takes about 0.5 seconds to authenticate a card and to verify the signature over the ticket. And in that time, we verify two cryptographic signatures. So that's pretty impressive for a small embedded system like that. And with that, I think my 10 minutes are up. So I hope this was a small appetizer for Java card and NFC. Thank you. Any questions?
So we have time for some question. Yeah.
There's one. In this case, it depends on how often you open the locks. It's basically shut off when it's not being used. And then if you push one of the buttons on the keypad, it wakes up. And then so if it's a door that's open 10 times every day, it's not the best solution. Then you need an electrical lock. But if it's a door to some room in a basement which is visited, once per month or maybe once per week, then it's fine. It should last for a few years at least. Other questions? There is one, I think.
How do you handle provisioning of the applets?
Good question. So one of the reasons why this chip is so secure is that in order to provision your applet onto it, you need to have a set of specific cryptographic keys. And within the NFC ecosystem, the role of being the gatekeeper and having those cryptographic keys and be able to provision an applet onto it is called a TSM, or Trusted Service Manager. So typically, we would establish a relation with a Trusted Service Manager, which could be a mobile phone operator or somebody who a mobile phone operator has a relationship with. And then once we have that relation in place, they are actually the ones doing the provisioning. Now, this is the way it works in some markets where they have started rolling out NFC projects, but in Sweden this hasn't really happened yet. So what we do is that we use NFC on a micro SD card. And in this case, it's only our application running on that, so we get the necessary crypto keys directly from the provider of the micro SD cards so that we can provision our applet onto it. And that's exactly the same as it is for contactless smart cards.
Okay, I think we need to